In today's N is for Networking, we continue our discussion of security enhancements with an introduction to MACsec. Now, if you hear MACsec and are reminded of IPsec, that's good intuition. Yeah, your head's kind of in the right place. But MACsec and IPsec are different things. They differ in several important ways, and we're going to get into that today. I am Ethan Banks with Holly Metlitzky, and in this show, I play the role of the network engineer who's been around packets for a long time, and Holly plays the role of the up-and-coming network professional who's parsing the protocols and putting the packet puzzle together. I like all that consonants. How'd I do? That was pretty good.
That was impressive.
Yeah, all right. Thank you. I pat myself on the back. Okay, I'll tell you what, everybody. Networking is a complicated stack these days, a big stack of technologies. And when you first start trying to get your head around it here in 2025, it is hard. And that is really the point of this show, to try to put all this stuff together. You can follow Holly and me on LinkedIn and the Packet Pushers Community Slack group. And please do. Both are free. Then you help to preserve our fragile egos as we see the numbers go up and to the right as you follow us and follow the show and so on. So keep us from getting depressed and add us to the people that you follow. We'd appreciate that. That's all we're saying. All right, Holly. So MACsec, this is your fault. You asked for this topic. So what brought it to your mind? Why did it come up?
So two things. I think the first was, maybe three things. First was, well, we've done IPsec. MACsec sounds similar, so seems like a logical next step. Someone actually messaged me about doing MACsec next, so why not? And thirdly, and probably most importantly, is I have one specific customer who requires MACsec for every device that they buy, or all their switches. Okay. And I thought, well, that's good to know, but that's as far as my conversation goes with them, because they're very technical and don't need me to do anything with their MACsec, just make sure the devices are MACsec capable. So I would like to take that conversation one step further, so that should they ever ask me a question about MACsec, I can actually answer it. That would be a good place to be.
Okay. So interesting fun fact from Ethan. I've never run MACsec in production before. I've been aware of it too, like you have, but never was in an environment that required it. So I know about it just in general sense, but have never run it. And so to prepare for this show, I did a lot of reading in multiple books across multiple vendors to really get a sense of what MACsec is all about. But if you're out there listening and you are an experienced MACsec networking professional and you hear Banks say something that's wrong or isn't quite right, actually is very welcome here. Please send us your actuallys about MACsec to packetpushers.net/follow-up and just clue us into the details that Holly and I might get wrong today. That said, Holly, I mean, we only got so much time and we're not going to get super deep in the weeds here, but enough that you'll have a pretty, hopefully, at least as robust an understanding as I've managed to figure out today, in all my reading and so on. So, okay, let's start at the beginning here. If we go the Eli 5 route, which, you didn't know what Eli 5 was as an acronym, which cracked me up. I thought that's what the kids said, and someone on the younger side like you but no.
Maybe the kids said that when you were a kid, perhaps. But I looked at that and I thought it was just another networking acronym that I didn't know. And upon researching it, I realized it was most definitely not a networking acronym. But here we are. I guess, yes, explain it to me like I'm 5. Eli 5.
Yeah.
Learn something new every day.
I'm 5. Well, I ran into it on Reddit. It was very common on Reddit, where there would be people talking in various subs about whatever technical topic. And it's like, okay, just Eli 5, explain like I'm 5, the very basics. So I thought we'd start there with MACsec, trying to keep it as simple, and then we'll get into more details as we move ahead here. Okay, so what is MACsec, Eli 5 style? It's a way to provide the same sort of security that wireless networks offer, but on the wire. So wireless networks offer integrity. Nobody messed with this in transit. And encryption. You can't decipher this without the keys. You get that over the air with wireless. But so what if we wanted to provide that in a wired network? That's what MACsec is in part. I read a few different accounts that kind of harken back to that as part of the why MACsec got started and what it's supposed to offer. Now, Holly, I'll give you a little more interesting history here. Old guy again, showing up to share some background. So way back in the day when wireless networks started becoming a thing and we were beginning to add wireless networks to our wired networks, wireless was like, it's radio waves that are in the air. And if you got an antenna, you can listen to the packets that are in the air. You could download them and do whatever with them. And so very quickly, wireless networks were encrypted with a protocol called WEP, or Wired Equivalent Privacy. Because in the beginning, it was like, hey, we need to give wireless networks as much security as wired networks have. Okay, that was the big idea. And then quickly, wireless networks advanced that they were even more secure than wired networks. And so the script flipped, and we ended up going the other way and driving MACsec. Now, WEP, if you've never heard of it, have you heard of WEP first of all? And do you know why you don't hear about it anymore?
Like, I heard about it in passing.
Yeah, WEP it got hacked, broken as a protocol many, many years ago, and it faded out and it was replaced with WPA, and now we're on WPA. Then it was WPA2, and now it's WPA3 in various flavors that do the job that WEP did in part, and a ton of other protocols that are involved out there. But that's a side note. That's got nothing to do with MACsec whatsoever.
Well, that was going to be my question, because you said all of this, like, in my brain, you would think that the wired would come first and then wireless.
Right.
But I guess that makes sense that one develops, and this is the problem with networking, is everything kind of develops simultaneously and influences each part of it, and everything continues to gain complexity.
We started with wired networks and added wireless later. And wired networks were hard to grab packets because you'd need to be plugged into the infrastructure somehow physically, which if you didn't have access to the network, that'd be really hard, right?
Yeah.
Wireless networks popped up, and all of a sudden, if you got an antenna, you can grab packets as they're going by. It's a little more complicated than that, but that's basically it. You now had access to network traffic that you didn't used to. And so that's why that evolution came. But then as wireless networks became so secure, it's like, dang, wired networks aren't as secure as the wireless ones now. What if we need that? And so MACsec. Okay, so MACsec is a layer 2 security mechanism. So we're talking about securing Ethernet frames and not IP packets. The IP packets will be secured as a function of this because we have an IP packet inside of a frame, right?
Yeah.
But where the security is happening and the network object that the security is happening on is an Ethernet frame. So you good with that? The layer 2 versus layer 3, the frames versus packets thing?
Yeah, 100%.
Okay. We talked about IPsec. Where was that happening?
So that's on the packet. Layer 3.
That's on the packet level. That's layer 3. Yeah, that's layer 3. So that's one of the big differences here between MACsec and IPsec, is that MACsec is happening at layer 2 at the frame level. So this is layer 2 integrity and encryption. If you don't have to do encryption with MACsec, but you can. And IPsec is again happening at layer 3.
Would you say that we see more of, I guess I see more of IPsec, and maybe I guess you did too, since you've never land up deploying a MACsec, but just because nowadays our networks are, I won't say predominantly layer 3, but predominantly layer 3.
I think you're solving a somewhat different problem with MACsec. It's not like I'm going to do IPsec or I'm going to do MACsec. No, they're not equivalent technologies. Yeah. Because layer 2 networks, you're dealing with your local area network, things that are inside your building, a common Ethernet broadcast domain where you're forwarding Ethernet frames based on their MAC address. Those are only locally significant. I can't do MACsec across the internet, right? That's not a thing. the, there are some big asterisk exceptions here for service provider networks. And if you're in a service provider network and you just said, well, actually, hang on, I'm getting there. We'll get there in a minute. Well, several minutes, because that's a detail most of us don't actually care about. But generally speaking, MACsec is for a local network, not going across the internet. It's a different animal. It's solving a different problem.
And I mean, I would think, looking at those two, people are usually more concerned with securing data that is leaving their network, because now it's traversing the internet or whatever, whereas you've got a little bit more control within your network, so perhaps you've got other encryption mechanisms in place that MACsec really is like an add-on amongst everything else.
Well, what you're really asking is why MACsec? Well, let's get there, but that is something. Let's get there in a minute. There's a couple other points I think that are worth making about MACsec to help us understand like what it is. So one I've kind of implied here is it's think of it as hop by hop encryption as opposed to IPsec, which is a tunnel that is over the top. Do you know what I mean when I say over the top?
Unfortunately, I do now with all our tunnel chats.
Unfortunately, because of the tunnel conversations.
Yes. Still.
Yeah.
We're working on
that. Are you going to a therapist because of your aversion to tunnels?
Maybe I should start.
Oh, man. Okay. So IPsec is this over-the-top concept where there's tunnel endpoints that could be separated by many different router hops. MACsec isn't like that. Again, there's some actuallys here, but generally speaking, when we run MACsec, it's a hop by hop thing. Host to the switch, maybe switch to another switch. It's got another MACsec connection between the two of them, and then a switch to a receiving host, perhaps, with yet another MACsec tunnel. That is a common way I'm seeing it deployed. So we want to think of MACsec in its typical deployment as hop by hop, as opposed to IPsec, which is a tunnel that can traverse many hops. Your brow is furrowed.
Yeah. So if you want, let's say, host to host encryption using MACsec, but that's traversing 2 to 3 switches between them, you now have to make sure, because it doesn't make sense for it to just be like, it needs to be configured the whole way through.
So here's our here's one of our actuallys for this episode as I was digging into this, because you said specifically something interesting there, which is host to host MACsec, which you can do. If the two hosts are in the same Ethernet network, they're part of the same Ethernet broadcast domain, you can run MACsec between them. Like, say there are 2 Linux boxes that have the capability of running MACsec. The switches in between would be just passing the MACsec frames along. When an Ethernet frame has been given the MACsec treatment, it's still an Ethernet frame with a source MAC and a destination MAC. It gets a new header, or it gets not a new header. It gets an additional header, and it gets an ICV value, the checksum value, the one that makes sure that the value hasn't been changed. What the heck does ICV stand for? Brain just went pop.
I literally read that right before this episode. I can't tell you.
I just looked at it last night. I put it in the script last night, and my brain forgot what ICV stands for. Not finding it. Well, there it is. Integrity check value.
Yes.
It's the number that is computed to make sure that the payload didn't get screwed with between source and destination. Anyway, those get added to the Ethernet frame along with the encrypted, if you chose to encrypt, along with the encrypted part of the Ethernet frame now. So as that frame is traversing the network on this, our scenario again is host to host MACsec. It can flow through switches, and the switches don't have to know anything about MACsec or interact with MACsec or do MACsec anything. They'll just like, hey, it's an Ethernet frame. What do you know? And send it along, forward it along based on the destination MAC and get it to where it needs to go. So that is a scenario that exists. But the scenario that seems to be more common as I was reading through documentation isn't that. It's more the host talks to the switch and builds a MACsec session. Now the switch needs to forward that frame on to the next switch in the network. And there's another MACsec session between those two switches. Or it's got to get routed, and the frame needs to go from the host to the switch and from a switch to a router. And there can be another MACsec session so one from the host to the switch, and then another MACsec between the switch and the router. Seems to be another pretty common deployment that I saw, where you'll end up, each hop has got its own little MACsec session between each device.
This seems like quite a lot of overhead if you've got a big network.
Overhead from a standpoint of you've got to do a lot of configuration on switches to make it all happen.
Yes.
That kind of overhead.
Yeah.
I think MACsec isn't as complicated to deploy as some other things I saw. It's pretty straightforward what it does, but let's get to that in a minute too. There's a lot of things we're going to get to in a minute here, but okay. So hop by hop encryption. We've talked about a few different scenarios, host to host, and what that might look like. And then I think the more typical MACsec enabled switches, like in your world of Juniper, you got a bunch of Juniper switches that can do MACsec. Pretty much from what I'm reading, the suggestion is pretty much any modern switch can probably do MACsec on some level or another. We'll talk about some of the different implementations here. But another point I want to make about, again, we're still in the explain like I'm 5 part of MACsec, but it's a standard. It is a standard that was created by a standards development organization, the IEEE in this case, and it is standard 802.11ae. That is the MACsec standard. Not that you care that it's 802.11ae unless it's a gimme on a cert exam or something. Which one of these is MACsec? And then you know that detail. More important is that every vendor that implements MACsec, in theory, should be interoperable. Now, this is a question I actually have. Is that true? Can I take a Cisco box running MACsec and make it talk to a Juniper box running MACsec and make it talk to an HPE box running MACsec? And is that all going to work? In theory, yeah, because MACsec's a standard, but
yeah, I don't. Whenever it comes to interoperability, there's always something that catches you. A tiny little detail sometimes doesn't work as should, but I'm sure it's done.
And for those of you out there that run MACsec in anger, in production, shall we say, just any of your commentary about that. Like, do you do multi-vendor MACsec? And did it suck to get it working, or was it like easy? Because, standards and standards. One other point for our Eli 5 section, Holly, that I wanted to make is MACsec is not an authentication mechanism from what I'm reading. It doesn't prove who you are, because that's what 802.1x is for. In switching, you've got the 802.1x protocol that accomplishes the authentication piece. And once that's done, you can get into the MACsec part of the conversation, if you will. So MACsec 802.11ae is going to handle the encryption for a host and the integrity checks and so on for a host that's already been authenticated via 802.1x.
Okay.
That jives? That works for you?
Yeah.
Okay. Because I'm waiting for you to be like, well, I was reading I'm waiting for you to, actually. So
No, so far so good. I mean, okay. You were meant to explain like I'm 5, and this 5-year-old seemed to have a lot of questions that we will get to.
In a minute. Yeah. Are we there yet? In a minute. All right. So here's one of the questions that I think you were asking, and it is, do we really need MACsec? Is that something that's in your head?
Because it just feels like, especially at that level, that layer, there's a lot of other encryption going on. Like the authentication piece with, let's say, 802.1x, that I understand, I've dealt with that a lot, comes up all the time, because obviously you want to make sure that someone's connecting to the network is the person that you think they are, whatever. But now when you start looking at encryption in that layer, well, what about all the other protocols and things you're hitting along the way that are already encrypted?
Exactly. And we've got encryption happening at multiple layers of the stack. So for example, we've got HTTPS, HTTP secure, that is SSL or TLS encrypted, and a bunch of other protocols that do the same thing. There's all these encrypted protocols. That's all happening at layer 7, where that payload's been encrypted at the application level. And then we got, the VPN technologies we've been talking about, like IPsec. We've mentioned WireGuard on this show too. And there's other VPN style protocols that are handling things at an IP level, layer 3. What the heck do we need encryption and so on at layer 2 for? So what is MACsec good for? I actually have had the same question, but I did in my reading come up with a bunch of suggestions for why. And again, going back to you out there listening, if you're running MACsec, why? What is your specific business? What's the business driver that caused you to turn MACsec on? Would appreciate hearing about that. But here's what I've come up with, Holly. One is you can secure some network traffic that you wouldn't have been able to before. So there are Ethernet control plane frames that are sent across the network as Ethernet that you could encrypt now. For example, Link Layer Discovery Protocol, LLDP. Do you know what LLDP is?
Yeah. Yeah, we use it a lot.
Yeah, I mean, it's an announcement coming from one switch going out a switch port saying, hi, I'm this host and this is my port and these are my capabilities. And there's a whole bunch of things that could be in that LLDP packet that could be really interesting to someone that's listening. And if they're able to intercept that frame, that could be interesting stuff. And then a bunch of other packets, or frames, similar. Link Aggregation Control Protocol. There's some DHCP traffic out there. ARP, Address Resolution Protocol, Spanning Tree. There's a bunch of things that potentially you can secure with MACsec. Although I will say, based on the reading I've done, there's a bit of make sure that the MACsec implementation in your box can actually encrypt everything that you need it to encrypt, because I did find here and there some notes and some exceptions where it's like, oh, well, we don't do, this one thing or whatever, which seemed odd to me. So that's a use case. If you're very concerned about someone intercepting your wired traffic and not wanting to do any intel gathering about your network infrastructure because of these very interesting control plane frames that are being sent around the network, okay, MACsec, that can help you out. Another scenario that I ran into in my reading was maybe you want to do MACsec, layer 2 MACsec here, instead of something at layer 3 or layer 7. That is, layer 3 or layer 7 encryption might have been an option, but not a good option for you for some reason, and MACsec's a better fit. And so you end up going with MACsec. And so there's a few different scenarios here I came up with. Based on some of my own history. One, maybe you're working at a place where you've got this in-house homegrown kind of legacy application. You can't update it for whatever, because reasons, to do any of the encryption. I've seen a few of these, and some of them aren't even IP apps. They only run over layer 2. Believe it or not, that's a thing. Not much of a thing anymore, but it's still out there. It's like, well, I want to apply some kind of security to this. Okay, maybe MACsec's your answer. You don't have to mess with the app. You don't have to have a programmer do anything to facilitate that. You don't have to work on the host that the thing's living on. If it's some ancient host with some very specialized operating system that comes up, you just let the switches deal with the MACsec, and at least you're getting it, hop to hop to hop, as the traffic flows through the switching infrastructure. Another scenario, maybe you don't want the compute platform to have to deal with encryption. You want to just okay, that would kill our particular CPU architecture to have to do SSL encryption maybe. That's hard to imagine that would be a deciding point for the most part, but maybe there's so many different ways to offload that, but maybe you just be like, I don't know, I'm going to MACsec. That'll do it. That'll solve the problem for us, and we don't have to have our compute stack do that encryption. I guess I feel like that's a stretch, but if we're talking about tools in the toolbox, and MACsec is a tool in the network engineer's toolbox, maybe that's a scenario where you're part of the big discussion and you're like, hey, we could do it with MACsec, perhaps. You're laughing at me. I know that feels unlikely, but and no one does this. No
like if you have the option, well, they do. They definitely do. If it's something
Now here's a couple of more interesting things that popped up here. Maybe you want to keep the payload of that Ethernet frame plain text for some of its journey and encrypted for the rest of its journey. So like in the first hop, you want it to be plain text because you're doing something with it. You're inspecting it, you're doing logging with it, and you need it to be plain text. But once it gets past that first stage and it's going through the rest of the network, now I would need it to be encrypted. And so you're going to go MACsec the rest of the way. Since MACsec has this hop by hop notion, you could do that. Couldn't do that with IPsec, right? Because if you wanted to do that with IPsec, you'd have to change where your tunnel endpoints are. And you maybe don't have as much flexibility there as far as where you're going to actually put your tunnel endpoints. So I think there's a potential use case there. Yeah, no? What do you think?
Sure. I mean, anything can be a use case. The idea of keeping a payload in plain text makes me uncomfortable, but I'm sure people do it.
So this maybe makes you feel less uncomfortable. What if you wanted to keep part of the payload in plain text? So this is another really interesting MACsec feature that I found. I don't know that every switch can do this, but there's something called an offset where you can say, hey, I need you to encrypt the payload, MACsec, but not all of it. I want you to use this offset of X number of bytes, some number of bytes. After that offset, encrypt the rest of it, but leave this first part in plain text. And here's the use case that I was reading about. You got a load balancer that needs to see that IP packet inside the frame and make a load balancing decision based on, it's probably doing some kind of hashing on like IP address and TCP or UDP port number, something like that, to figure out what pool member to send that traffic to. Well, if you've encrypted it all because MACsec and it can't see it, then it can't load balance as effectively. And you may end up with too much, one of the links or one of the pool members being overloaded with traffic. Mm-hmm. So you use the offset feature of MACsec so that that part of it, just the header part, the IP header and the TCP or UDP header, is in plain text so that it can be read by the load balancing device, but not the payload. So again, interesting. And I don't think you can do that with IPsec. I'm not familiar that you could do that with anything else. I've never run into an offset feature like this, like you can apparently with MACsec, or at least some implementations of MACsec. I don't know that every MACsec box could do this, but I thought that was like interesting because I can imagine scenarios based on different networks I've worked in where maybe we would have used that.
Yeah, no, I like that.
Yeah, it's interesting. Yet, I guess the final thing then is maybe you're just a hyper secure environment. And this is where I'm looking for those well actuallys, where you guys are out there and you're like, yeah, I'm in high frequency trading and our whole back end, the whole network is our secret sauce. We do not want anyone that manages to break into a data center and stick a capture device on one of our lines, capturing our Ethernet traffic to see anything and learn anything. No, can't have it. Got to have MACsec.
And those are the customers that I've seen it in, or like the financials. It's where I see MACsec. Yeah.
Okay, that jives then. My intuition was right. Because those guys that like the high frequency trading guys, I've heard some stories from them and how some of the neutral trading floors are set up. They measure the length of the fiber optic loops connecting them to the network. Or at least that's what I've been told. I've never seen this myself, but that's how crazy some of this stuff is. Like if you're neutral, you're not going to give this company an advantage over this other company or this one hedge fund over another hedge fund with the length of the cable being longer or shorter than another. Yeah. That's how nuanced and crazy they get. Because this information is considered so valuable because of the timing of the trades that they make, where microseconds matter. You make a trade too late and the price might have changed and now you're losing money on a trade where you would have made money a little bit sooner. So you're
really a little bit closer and now you're making money.
Yeah, exactly. So again, that hyper security, I think, is part of the MACsec magic, and where I'm hoping if you're listening to this, you can be anonymous. We don't need to know who you are, or the company you work for, but if you just state what your use case is, maybe we share that on a future show. That would be really interesting. Again, packetpushers.net/follow-up, and send us that information. We'd love to hear from you. Okay, so MACsec implementations, Holly, we talked about the host to host, where the switches aren't really engaged in MACsec, and they're just passing an Ethernet frame through that has been modified by MACsec, and that's fine. It still looks like an Ethernet frame, and a switch can forward them. Or I think the more common scenario of the host is talking to the switch, and the switch is talking to another switch, which is maybe talking to a router or talking to another host, as the case may be. And there's and everything is MACsec, but unique MACsec sessions, device to device to device. Again, for you, as you've been dealing with customers, you haven't run into any of their MACsec implementations beyond, hey, your box does MACsec, right?
Yeah, I mean, most of these networks are long-standing networks, so it's replacing boxes that are already there. But I should ask if they'd be willing to chat to me about it.
Yeah, that would be just interesting to, knowledge to have in your head, how they're actually implementing it. From the documentation I read from both Cisco and Juniper, it feels like what the documentation is guiding you towards is that hop by hop method, how to set up your switches so that they are negotiating MACsec with their peers, standing up a MACsec session, determining which of the members of the MACsec pair is going to be like the key distribution point for distribution of keys, and related functions like that. It felt like the assumption was, we're doing MACsec hop by hop by hop here, switch to switch, switch to router, switch to host, a host to switch, etc. The only place I saw host to host referred to in my searching was Red Hat's got a page that seemed pretty popular in the search rankings, where it's talking about, oh, you got a Red Hat box and you want to do MACsec between this server, your Red Hat server, and this other Red Hat server. Here's how you do it. And they don't even talk about doing MACsec to the switch, as I recall. Maybe they do in those docs. I don't think so. I read a lot of documentation, so I could be confusing things. But I think the context was mostly from one server to another using MACsec, and they explain, hey, they got to be on the same network, and and all of that. But certainly from the docs I was reading, from a host to a switch is also a very common scenario that folks seem very, very aware of and would be commonly done, to the point that you can say on an access port where that server's plugged into, hey, if the host doesn't talk MACsec to me, drop it, drop the traffic. You can get that aggressive with your configuration, where you can insist that if it's not a MACsec conversation, we ain't having the conversation. So if that kind of implies host to switch is definitely a very common scenario that everybody's used to.
And in that scenario, I'm guessing any host that now connects to your network has to be pre-configured with said MACsec.
Any host, or right, yeah. The presumption would be that the host has been configured for that. Yeah, exactly. Although there are, the way you configure the switch, there are a bunch of ways. You can be that super mean, if it's not MACsec, I don't want to talk to you kind of setting. But it could also be, well, we prefer it to be MACsec, so try to negotiate MACsec, but if the host can't talk MACsec, it's okay, we're going to let it through anyway. You could also set up that scenario as an option, and variations in between is what I noticed. So, okay. So why don't we close off the conversation, Holly, with how MACsec works at a high level? Because, man, if we got into all the details, I was glazing over trying to take it all in, because as like with every protocol, there's the high levels, the basics, and then there's like, well, there's this corner case. Well, what if you want to do it like this? And what if you want, well, in this scenario, you can do, and 38 paragraphs and a whole bunch of configuration commands later, you've figured out that little corner case and so on.
Which we don't need, since how many years have you been in networking and you've never configured this? I think we'll be okay with a high level understanding.
Well, I've never worked in an environment that needed it, right? So
Yeah.
I think if I was working for like there's a company that has done some shows with packet pushers called Jump Trading. I bet, I don't know, but I'm going to guess Jump Trading would be like a great candidate for this. High frequency trading kind of a shop, and so on. I bet they run MACsec. Even though I worked for financials for a number of years, didn't run into it. It just didn't come up. Was encryption important? You bet. Did we have, crazy Talus boxes doing magical hardware encryption with a super secret locked vault, and all the rest, and a rack with a physical key that only certain people had access to? Oh yeah, we had all that stuff. MACsec? No, we didn't run MACsec anywhere. So yeah. Even as crazy secure as some of those environments were that I was working in, just that didn't work. Didn't happen to me. So. All right. So how does MACsec work? I'll give you my basics. Here come the actuallys. I can hear them now. But there's, like with a lot of security protocols, there are keys, and there's a key exchange that happens between the two MACsec peers. And they use a protocol called MACsec Key Agreement, MKA, to facilitate the key exchange. We are not going to break down how exactly the exchange works and so on. I will mention a footnote because if you start digging into MACsec, you might run into this and it might confuse you. Back in the day, Cisco used their own protocol for key exchange. They called it Security Association Protocol, SAP. But that is old news. Cisco does not recommend SAP anymore. They recommend all their MACsec implementations use MKA going forward. MKA is the industry standard for key exchange. So that's the first part of MACsec. Does that jive with what you've run into, Holly?
Yep.
Okay. So we're in agreement there. All right, good. So I say key exchange just so you know that they got to agree on keys, and keys can be rotated. Keys can be dynamic in certain implementations. We're not going to get into all of that today. I don't even have all of that in my head, honestly, other than a kind of a very general sense of how all that works at a detailed level. MKA is the key, the protocol, though. And if you were like getting some kind of a mid-tier security certification, you might need to know more details of exactly how MKA works and how to enable it, turn it on, and tweak it a little bit to fit your particular environment if you were you're going to run MACsec in production. A MACsec frame, then, what does it look like? Because we know what an Ethernet frame looks like. We got a source and destination MAC. We've got, I don't think we've talked much about ether type, but there's an ether type field. Did we mention that before? Does that ring a bell with you?
I don't think so.
Yeah, the ether type field basically tells the switch what's coming up next in the rest of the Ethernet frame. Like, oh, it's an IP packet, or it's this, or it's that. It's like it's a hex value that is metadata about what else is in that Ethernet frame. I just mentioned that to say when an Ethernet frame has had the MACsec treatment, the ether type changes to let the system know this is a MACsec frame. That's what this is now. Now, what you're seeing coming up next, that's MACsec. That can be useful for, as I understand it, for hardware ASICs that are looking at the Ethernet frame can read that value and understand and treat it in some particular way. I'm not going to, again, actuallys, you're coming at me hard here, maybe, but yeah, so I'm just going to leave that alone. Mostly just to say an Ethernet frame that is a MACsec frame has a particular ether type of value that is set to it. I didn't note the value down. I just wanted to mention
it
that.
exists.
It exists. And then once we're past that ether type value, whatever the number is, I didn't write it down. Like I said, there is, you will find a MACsec header that has been added to the Ethernet frame of some number of bytes. It's either 8 or 16, if I remember right, depending on reasons. It's not always exactly the same length. But there's a MACsec header there that's got some information. And then there's an integrity check value field, the ICV field in the tail. That is used to ensure data integrity, that the frame wasn't messed with along the way. The payload of the Ethernet frame is encrypted. In other words, you can't decipher the data if you don't have the keys. So it's encrypted. And it is optional. You don't have to encrypt with MACsec, but I think that's typical. Why wouldn't you?
Yeah, why are you doing MACsec if you're not encrypting it?
Well, same question about IPsec, right? Why do we have
Mm,
tunnel and transport? Why do we have the option to encrypt or not encrypt? There's different reasons. And well, with IPsec, there's trade-offs for sure in that, well, if I don't do the crypto computation, if I don't have to do that math, I'm saving myself some compute. You don't really have that problem with most MACsec implementations, as I understand it. Uh, so let's talk about this. Encryption for MACsec is done with the AES-GCM algorithm, the Galois/counter mode algorithm in either 128 or 256 bits. I saw those both very common. And what's interesting about GCM, the Galois counter mode, is it handles encryption and integrity in a single operation, and you can encode it in hardware. You can build silicon to
yeah.
do this operation and have it be really efficient and work really, really well. And here's why this matters. I don't know if you've read ahead or not, but I'm going to ask you why you think this matters. Because if we're doing this on an Ethernet network and we buy Ethernet networks because they're fast, what would we be worried about with MACsec?
Well, that's, I think in the beginning I mentioned my concern about overhead, both from a technical standpoint as your network engineer, but also anything you're doing to a frame or packet may slow down how it's processed. So you have to now encrypt and decrypt this frame. That may take a lot of time if it's not encoded onto the chip.
Absolutely nailed it. Exactly right. And we're always concerned about that as network engineers. And it's one of the things I know we've mentioned in some past shows. When you buy something like a firewall, let's say, or a router that can do crypto, and you see specs from the vendor of its wire speed, how many packets per second it can push, and so on. A lot of times those numbers go down if you add encryption, or if you add an inspection, or you add some functions that the packet has to get looked at or munged in some way by the box. Your throughput goes down. Not with MACsec. You shouldn't have that problem. AES-GCM works so well in silicon, and it is so efficient in that the operation does both the encryption and the integrity part of all in a single operation, that the crypto engine is built into the PHY, the PHY part of the switch. Do you know what the PHY is?
No, pre-reading this, did not know what that was.
Okay, so now we're getting into the nuts and bolts of a switch and how it does what it does. So at some point, the switch has got to take ones and zeros and turn them into an electrical signal that matches, or optical signal if it's optical.
Yeah.
But that is sending out light or sending out electricity in a specific way that is coded for Ethernet, right? That's what the job of the PHY. The PHY would be where you're plugging the cable into. It would be the optic, the part of the optic that the cable, the fiber optic cable actually plugs into on the front of the switch. It's the thing that is converting, the ones and zeros into magical layer 1 Ethernet signal that you would look at in an oscilloscope, let's say, and see what's happening. So where MACsec is happening on most switches, as I understand it, is right there in the PHY. That means MACsec is happening at line rate. So if you got, 100 gigabit per second link, 200, 400, 800, if that box can do MACsec, it's not slowing you down. It's not like, oh, our throughput just got cut in half because we turned MACsec on. No, it does it at line rate. Which I suppose, going back to the part of our discussion earlier, why MACsec? Well, maybe this is why, because it doesn't slow anything down. You're doing it at line rate.
Which I think also is why some boxes don't, like, I know you mentioned most boxes should have MACsec, but the thing is, it's not just something being done in software. Like, this is on the chip itself. So not every chip is created to have this functionality.
So let's actually get into the nuance of what you just said, because you just said chip. So there's multiple places that we could be doing this encoding and decoding of MACsec. Now, we mentioned the PHY, the physical place on the switch where its signals turned into Ethernet and sent out across the wire. We also have switch ASICs, right? The
Yeah.
chip inside the switch that is separate from the PHY. That's a different part of the box. And from what I was reading, there are some switches where the architecture is not for the PHY to do MACsec, but the ASIC to do MACsec. And if that's the case, you need to be a little more careful about performance impact, because it's now you haven't baked it right into the Ethernet receiver transmitter. Now it's upstream. It's up a level in the ASIC of the switch. So, okay, that's a potential thing. But I couldn't give you like model numbers or anything where like, oh, this one does it in the PHY and this one does it in an ASIC. I think basically they all do it in the PHY from what I can tell, so that it's line rate. It's a MACsec is a line rate operation. I don't want to say you can take that for granted and just assume that that's always true, but I kind of think that's the case. And again, if you're out there running MACsec in production and have opinions, share them with us. We'd love to hear some more of your thoughts on that. From what I was reading, if MACsec function is up in the ASIC, that might be like microseconds of delay for the encrypt and decrypt, which isn't a lot, but it can be a lot, high frequency trading. Whereas the PHY, you're dealing with it in nanoseconds, so it's extremely fast. Nanoseconds, is that millionths of a second? No, that's microseconds. I don't forget how much nanoseconds.
I think
billions?
nanos to the -9. If my, I don't know, primary school maths still serves me.
Yeah, my memory's faded. I just, microseconds is fast, but in computer time, not that fast anymore. And not when we're talking about like port-to-port latency in a switch. You care about nanoseconds and even sub-nanoseconds in some cases. Okay. And then the final place you could be doing MACsec encryption would be in software and using a general purpose CPU. And that's going to be slow, relatively speaking. But I mean, if you're on like a server that's running, a hypervisor, VMware or something, and it's MACsec capable, well, that's where it's happening, unless you've got some special offload card or something. I'm going to guess there's some kind of a smart NIC or a DPU or something like that, where maybe you could offload MACsec in the server to that card. But generally speaking, it's going to happen on the CPU. So do you get line rate MACsec on a box on a server that's got 100 gig uplink to the network? Don't know. I'm going to guess no, because there's a lot of other stuff that box has got to do. So, I don't know. I'm speculating. I don't actually know from having, again, run it in anger, because I haven't. But yeah. And I guess the big point here is you got to make sure that the hardware that you're using supports MACsec and supports it in the way you think it supports it. Would be my point. If you're an engineer or an architect and you're doing a network design and MACsec matters to you and you really need to know the nuance, don't assume, dig in, make sure you know exactly what that box is doing and how it's doing it, because that might actually matter for, like, if you have to build a very specific latency profile for the application you're supporting or something, it could make a difference. Don't just say, oh, MACsec, it does it, box checked. It might be that simple, but you might need to dig in a bit more and ask some harder questions. Okay, Holly. So, we crammed another half-hour conversation into almost an hour. Well done us. How are you feeling about MACsec at this point?
Better. I think our whole conversation about the PHY and where it sits was really important, because obviously I'm dealing with financials, so that's definitely going to be a consideration. And just interesting to host to switch, hop by hop, like all of these little things that you don't really think about until you get into the high level nitty gritty. But it's good to know. It's important to know. And, all these things are considerations when designing a network. So you have to be aware of all of the factors that could slow it down or what you actually need.
I think what'll be interesting for you when you're like building a bomb for a customer, bill of materials, not that kind of a bomb, bill of materials,
I
for
understood.
A customer is if you start getting into the optics and digging into the specs of a particular optic that they're going to be using to populate a switch with, is see if you can find someone within Juniper that like knows all about that optic or something and say, talk to me about the crypto engine for MACsec. Is that's built into this optic, right? And see if you can find some nerd at Juniper that actually knows in detail and will talk to you about it. Because that person exists, or those people exist.
And if I come to 100%, if I find that person asking that question, I'm 99% sure they will be extremely excited to have that conversation.
Yes, they will, because when that person's like, you knew enough to ask me that question. Let's talk, and it's gonna be a
I've been waiting.
Exactly. Okay, well, let's bring this show to a close here. I hope that you enjoyed this introduction to MACsec. There is a lot more to it, guys. There really is, including, like, we didn't talk about how MKA actually works. We didn't talk about details of managing keys, which is a whole other thing. We didn't really talk about integrating 82.1x authentication into your MACsec scheme. We didn't talk about using a radius box like Cisco ICE, let's say, to push MACsec related policy and more. There's more stuff that, again, way beyond the scope of the discussion today. And I think any day, I don't think we're going to get into MACsec any more deeply. This was a pretty good intro. And I think MACsec is kind of a deep enough niche by itself that unless a bunch of you really, really, really want us to do more MACsec, I think this is probably as deep as we're going to go. Because now you know enough to be dangerous. So, yeah. Okay, like, subscribe, tell all your friends about N is for Networking. Find the video version of this podcast on the Packet Pushers YouTube channel. You can see Holly and I as talking heads chatting with one another. And of course, the audio version of this pod is anywhere you get your podcasts. And send those follow-ups and your well-actually comments to packetpushers.net/follow-up. Holly and I do love to hear them. We read them all. You guys are hitting us up in LinkedIn with DMs. You guys are talking to us on Slack. You're using the form there, the packetpushers.net/follow-up. This is awesome. And we're going to have another Well Actually episode pretty soon. We'll share some comments in the coming weeks. It's coming up. We do appreciate that. You can also send us voice memos. So record your voice memo, like you talking into your phone, and then email that to n4nvoicemail@packetpushers.net, and the number 4n voicemail at packetpushers.net. We're going to splice them into a show in the future. We think that would be cool. So just, send us your voicemails. Okay, I've been Ethan Banks along with Holly Metlitzky. You can connect with us on LinkedIn or the Packet Pushers Community Slack channel. And again, a lot of you have done exactly that. It's been fantastic to hear from you all. Last but not least, just remember, networking isn't hard. Other people figured it out, so you can too.